Hey, FOSDEM. I'm Emmeline Friedman, and this is Michael Heshin, and we are from Neighborhoods. I am the comms director and ecosystem development person. Michael's the core developer, and I'll let him introduce himself when he gives a little demo. So, what is Neighborhoods? Um, Neighborhoods is a groupware and socials framework for the distributed web built on Holochain. And what we mean when we say groupware and socials framework is kind of summed up in this little motto that we like to use, which is generic tools, specific cultures. So what we envision is basically really lightweight, modular holochain apps with basic functionalities like calendars, chat, collaborative docs, decoupled from reputation and group culture metrics. So those are things like entry and exit rules, engagement incentives, likes or claps or other affirmations, and visibility and feed ordering algorithms. And so, of course, on a platform like Facebook or Twitter, you get a lot of these basic functions, but they are necessarily coupled to, the company's culture metrics, what their rules of engagement are, how they think your feed should be ordered, that sort of thing. So we want to decouple these, and that's what we're calling neighborhoods. So like I said, you can basically bundle generic tools with specific culture. And so specific culture is kind of like what we're working on internally. So these are things centered around reputation, activity records, and group relevant metrics. And so really sort of the special sauce of neighborhoods, or like what's at the heart of neighborhoods, is a reputation language, like a language built just for reputation that we're developing, and a reputation interchange. So also the means of selecting, storing, and passing reputation data within and across neighborhoods. And so at the user level, what this means is that you can connect like a reputation portability extension to HAP modules. And so what we think Neighbourhoods offers to groups is basically design choice for culture in social spaces, which is something that you don't really see either on the centralized web or in many dWeb spaces, that are kind of run more through tokens as like the be all end all for access, for governance, and for how one is sort of known in a space. So Neighbourhoods offers reputation and cultural libraries for various use cases, and also a means of plugging these into HAP DNAs, so like the core code base of a Holochain app. And so what this translates to for us product-wise is a setup wizard for choosing these HAP modules and then for pairing them with reputation data types or other reputation libraries, and also dashboards for community governance of these ultra important metrics. So again, for individuals, the name of the game here is basically reputation portability, an ability to leverage reputation from one social space, like from one neighborhood to another. So because it's Holochain, individuals' activity records and the metrics that are used in any social space, any neighborhood that they're interacting in, are stored on their devices. So they can be reliably shared into other neighborhoods just using Holochain's native validation rules, obviously, pending various agreements across neighborhoods. So what this translates to for a user member is like a browser extension for reputation data. So you can kind of think like the least complex version of this is sort of like raw-ish data that doesn't have a lot of, that's not very visible, but simply denotes a neighborhood of origin, to like badges that aggregate and that value that activity. Say if two neighborhoods have sort of reciprocity agreements and trust each other's cultural metrics. So who is this for? This is obviously quite centered on the Holochain ecosystem. And a lot of our motivation here is sort of making, is wanting the Holochain ecosystem to traffic in very rich and contextual data, but also, really enable that portability across social spaces. So centered on Holochain, but also hopefully useful for dWeb communities and projects that want to use data generated in specific contexts for more than just ownership claims and token counts. Our sort of go-to example would be, different sharing economy style spaces where, if you've done a bunch of transactions or you've done a bunch of rides or you've shared your couch or, whatever the use case is, you can actually go into a new community with that badge that basically denotes like, hey, I have let people into my home and everything turned out all right. And so if those communities trust each other to any degree, your reputation badge and your reputation data from that social space of origin ostensibly has some meaning. And obviously that's something to build out and to be thinking about into the future. So, it's also essentially like a groupware engine. So it's very much for people who want to create lightweight peer-to-peer tools for social and sharing groups. And we are pre-product now, so that likely means that we will be talking in the near term to developers like you. So with that, I will turn it over to Michael, who will demo and talk a little bit about the language for reputation and also the reputation interchange.
Cool. Thanks, Emmeline. Let me share. Okay. Hi, I'm Michael. I have a background in programming language theory and Haskell in the past, and now Rust and Holochain. Cool. So what is Replang? Emmeline mentioned this name. It's a small programming language interpreter built in Rust that I'm the main author of. It's basically the simply typed lambda calculus with Hindley-Milner type inference over it. Right now, it has just integers and booleans and pairs of values. So you could have pairs of whatever, but only integers and booleans as the terminal types. It's Turing complete, but still pretty prototypey, so you wouldn't necessarily want to build large things in it at present. We plan to add structs and enums and modules and what you'd expect from a kind of typical language later or soon. Why do we need Replang? So it supports dynamism of reputation computations. And what does that mean? As an example, say we have a feed of some sort and we want to change the ranking algorithm that determines the ordering of posts in that feed. If we baked that scoring computation into the HAP, Holochain app, then in order to change the feed, we would have to get everyone in the network to update to the newest version of the HAP, which is kind of onerous in a distributed context and could lead to network forks or just be kind of annoying. With Replang, we have programs that are just values that can live in a DHT as like any other Holochain data. And so the Replang interpreter can load those values, those programs, interpret them, and feed in other Holochain data. And therefore, for this example, could compute the score of each post using whichever computation it's told to run. And so basically updating this feed ranking algo is as simple as the network propagating around a new entry type and deciding that that is the new feed algo. And then everyone's interpreters will load that and compute scores appropriately. So yeah, that's this kind of dynamism. And there's also a notion of like expression of reputation data coherently across different HAP contexts, and having a language for that supports coherence because if reputation can be expressed in one context, someone else in a different context can still integrate that information because they have this shared interpreter, shared language. And that ties into data portability. Cool. So some context on the demo. This is kind of core functionality. It's not what end users will likely see. Yeah, it's kind of nitty gritty, so fair warning. It showcases the interchange entry, which is basically first contact between Replang and Holochain. It is a Holochain entry type that stores Replang programs inside of it as expressions. And yeah, as such, programs are just data. And validation of interchange entries occurs using Holochain's validation rules, just like any other data in Holochain. Except that in this case, we're actually running a whole programming language interpreter in the Holochain validation triggers, basically. Because it's all written in Rust, you can just do that and it works. So this is similar to smart contract, how smart contracts on blockchains perform validations, such as Ethereum and the EVM, except that there's less redundant computation with Holochain because you can tune this threshold of how many peers need to validate entries. Cool, okay, demo. So on the left, we see, oops, the first conductor, and on the right is the second conductor. And over here in the next pane, next window, we have 2E1 and 2E2 connected to the respective conductors. So let us create an example program. So we're going to add 1 and 2, which should be 3. And we observe that it shows up in both conductors, which is just Holochain syncing entries. And we see here that operator, which is the computation, is adding 1 and 2. There are no operands. Operands is where, as I said before, for the feed ranking algo, we might feed in other types of data to a scoring algorithm. But here we aren't feeding anything in. So it's just adding 1 and 2, which has type int and output value 3. Cool, kind of as we'd expect. Now we can construct an entry which refers to another entry, and that'll show off kind of reference and operands. So we see +1, which has type int to int. It takes an int and returns an int. And down here in the selector, we have an option, which is that previously created 1 + 2 = 3 entry. So we can select that and create, and we see on both sides this new bigger entry, which has an interchange operand with a Holochain header hash referring to that first created entry. And we see the output value is 4 as we'd expect, and the type's int as we'd also expect. Now we can do something a little bit more complex we have the operator plus, which takes an int and another int and returns another int. And now we have two options. These previously created interchange entries, and we can create and observe on both sides again that we have successfully referenced these two previous entries and computed 7, which is what we'd expect from 3 plus 1, adding those to 7. And so here in the background, invisible to us, validation is occurring, where when the conductor on one side creates an entry, it's invoking the Replang interpreter to compute that like 7 or whatever it is value. And the other conductor, when it receives the entry, is also performing that same computation in order to do validation. We don't see it because it's all passing, because no one's trying to cheat here, but entries that are invalid would be flagged, and this supports more low trust environments, or the ability to kind of trust but verify. Cool. So yeah, that's kind of the demo. And next up after this is what we're calling the NH MVP, which is already in progress. It's a app for meme sharing. And what that means is basically users can upload images, view images, and then sort their feed based on different and user-defined scoring computations. And I didn't put it here, but the computations are based on affirmation data types, such as likes or claps in this case. And so users can like or clap for a post, and that feeds into the scoring computation and dictates the feed ordering, basically showing that we can, as I said earlier, use different scoring computations without having to redeploy the whole network, and that users can author their own computations instead of being kind of stuck with what is handed to them, as is the case in most platforms right now. Cool. And yeah, so we just raised money looking for collaborators potentially. We're kind of in this interesting intersection, or at least the dev work of interpreters and Holochain, and supporting these higher level constructs like mimetic bridging and the interchange, which supports generic tools and specific cultures, as Emmeline said. So please reach out if interested.